Okay, so I'm going to try to do this. It's worth my time since some other students probably need to know this and I want to see how it works. Two things I want to say at the start. For physics, first of all, you should always have pictures in your head for everything you're trying to understand. Okay, you don't understand things through words alone. That won't work. You need to have pictures in your head for every concept. And then the way you piece those pictures together is how you understand the ideas. So you have a whole bunch of different pictures in your head. Some of them come along with words. And the way you put those pictures in sequence or next to each other, or the way you connect those pictures in your mind, is how you understand the concepts. The other thing to say is you need to start from the ground up. Always go back to basics. If there's a concept you don't understand, it's probably because you have misunderstood one of the more basic concepts. You know, in physics we start with extremely simple concepts and then we build up. We put the simple concepts together and we keep putting them together to make more and more complex concepts or objects. And if you don't understand a certain thing, it's probably because you don't understand a certain part of it. So, we'll start with the basics. I mean, this is the super simplified rundown, but in any case. So, an atom is a thing that has protons. Perhaps let me use a different color. It has protons, some number of protons, right? Different numbers of protons will give you different atoms. If it's one proton, you have hydrogen. 2 protons, you have helium, etc. Some number of protons. Okay, I'll put etc. here. And then some number of neutrons. That's not really important. The number of neutrons don't have a big effect on the behavior of an atom. But there's some number of neutrons. Okay, and then electrons. And you'd hopefully know the electrons fly around on the outside like this. And you have some number of them. Let me just write etc. again. By the way, the number of electrons and the number of protons should be the same in a neutral atom. Okay, so we have that idea. That's an atom, simplified idea of an atom. Let's put a circle around it. Now, the reason I'm putting a circle around it is this is our picture of an atom. The circle that I've drawn around here, there's nothing, that circle doesn't exist. There's no circle like that. That is a circle in my mind, and I'm putting it there because I want to remember that that is the picture of an atom. Okay, everything inside this picture is an atom. So I'm going to just forget about that for now. I mean, I still have to understand how it works, but in order to see how the picture is incorporated into a larger picture, I will need to forget the inner workings for now. So this is my atom. Okay, I'm going to sort of try to shrink it down now. By the way, let me just do something like this. We're going to sort of, maybe let me use gray. We're going to sort of ignore what's going on inside an atom. We can't completely forget, but it's some details that we might need later. For now, we're going to just take this circle that I've drawn and say that is the picture of an atom that we will work with. Oh, one thing I didn't say, which you mentioned, but let me just clarify. Let me be very clear here. I asked what holds an atom together. Well, an atom has protons, which are positively charged, and an atom has electrons, which are negatively charged. Positives attract negatives. That's it. That's what holds an atom together. If I look here, you have to be very careful. Look at this statement. I'm going to clear up a lot of confusion here, hopefully. Have a look at this statement. What holds an atom together? Okay, think about that statement for a little bit. It has two interpretations, which both seem fine. It could mean, now both of these interpretations are valid. This is not a silly thing to think. It could mean two things. There are two interpretations of this, and they are both equally valid. When you ask a question like this, you need to be very careful. Which of these two meanings are you using? You're either saying, your one interpretation is, what keeps one atom together? So you have one atom, it's not falling apart, it's staying together as a single atom. What's keeping it like that? That's the one interpretation. The other interpretation of this question is, what keeps an atom close to another atom? I hope you can see these are both valid interpretations. If I ask you what holds, or perhaps I should have said what holds atoms together, maybe that's better. Okay, so let's sort of cross this out. There we go. What holds atoms together? If somebody asks you, like I asked you, what holds atoms together, you should ask me to clarify what I mean. When I ask what holds atoms together, do I mean what keeps one atom from falling apart as a single atom, what stops it from splitting up into its individual pieces and not being an atom anymore? What keeps an atom as a single intact atom, together as an individual atom, instead of just falling apart into protons and neutrons and electrons? Do I mean that? You should ask me, do I mean that meaning number one? Or do I mean this meaning number two? Am I asking what keeps one atom together with another atom? And those are different questions. I hope you can see the difference. If you don't understand how these two questions are different, you need to probably pause this video now and think about it. You need to understand why these two questions are different. They're not the same question. Okay. Compare it to when you're talking about human beings. Then one interpretation becomes obvious and the other one becomes silly. So you can see why they're different. If I said to you, what keeps Russians together? If I were to ask you that, what keeps Russians together? Obviously, I mean what keeps different Russian people in a community together. And you could say the Russian language keeps them together, or the Russian culture keeps them together, or the borders of the country of Russia keeps them together, the police, whatever. That would be the answer to this question. What keeps Russians together? I, of course, don't mean, if I ask, what keeps Russians together, I'm not asking you, think about one single Russian. What is holding him or her together? What is preventing that Russian's arms from falling off? Or what is preventing that Russian's body from exploding? That's not what I mean. So now hopefully you can see why these two questions are different. The one interpretation means think of an individual object, what's preventing it from falling apart. The other interpretation means think of many of these objects, what's keeping them together as a collection. Those are different questions and you need to always know which one you are talking about. Otherwise you're going to get confused. So let me at this point I can answer question number one. I'll answer question number one. What keeps one atom together? We have to look inside the atom to check what is preventing the atom from falling apart. That's the thing I was just talking about. It's the electrostatic force that hopefully you've learned about before. It's the attraction between the negative electrons and the positive protons. By the way, that's called the electric or the electrostatic force. So that is the answer to question number one. What holds a single atom together? Okay. Now, in order to answer question number two, you see why it's important to differentiate between these two questions. In order to answer question number two, I need to introduce another atom into my story. Over here I've got a picture of a single atom. I need to introduce another atom, and it's going to be a picture of an atom just like this one, except it will be representative of a different atom. The reason I need to do that is so I can explain how two atoms can be held together. Okay, so in order to do that, I'm going to just try and move this out the way. Okay, we're gonna just have to remember these things. This information is still important. Okay, so for now, just gonna put it somewhere else. Okay, let me try and grab this. This is our picture of an atom. Let me shrink it down. Do you see why it's not really important how much I shrink it? We know what's inside. We've discussed it. It's the end of the story. We don't need to discuss atoms anymore. We don't need to discuss what is inside an atom. We can just say, okay, well, there's our atom. I should probably use black. We can just say there is the circle we originally drew. I'm going to try to put it in the same place. There's our circle. Inside that circle is our picture of an atom. We're not going to think about it. We want to think about another atom. So let's do it like this. I'm going to make a copy of this atom. Here's another one. Identical. These atoms are different. They're not the same atom, but they look the same. They are identical in appearance. These may both represent helium atoms, or they might both represent hydrogen atoms. Whatever type of atom this one is, this atom is the same type. And they might be different. In general, you might have a sodium atom here and a carbon atom here. So just usually, there's no reason why two different atoms need to have the same picture inside. They're only going to have the same picture inside if they are the same atom. But hopefully this is making sense. What's inside the circle represents the type of atom that I'm talking about. So these two pictures are the same picture because they represent the same type of atom, the same element. But they're not the identical. They're not the same atom in terms of what I mean is I can't say that this one and this one occupy the same place at the same time. Something like that. They're more like identical twins. They look exactly the same. The picture that describes them inside is exactly the same, but they are actually different. Okay, so here now we're dealing with two atoms. You should understand there are three ways that these two atoms can be held together. So now we are answering question number 2. What keeps an atom close to another atom? There are 3 ways that they can be kept together. This atom can be attracted to this atom in 3 different ways. And here they are. The first way is a covalent bond. In this video, I can't cover what makes a covalent bond a covalent bond. You can go check that out, find some other resources. The second way is an ionic bond. And the third way is a metallic bond. Those are the 3 things that keep different atoms together. Even though the atoms might look identical, in other words, the picture you have for this atom is the same as the picture you have for this atom. That just means they are atoms of the same element. But it's still 2 separate atoms in physical space. They can be held close to one another by these 3 things. And that's it. There are no other options. What do we call these 3 things? All together, these 3 things are called chemical bonds. Okay? In any one of them. A covalent bond is a chemical bond. An ionic bond is a chemical bond. A metallic bond is a chemical bond. In other words, this is a category, and these are 3 things in that category. Like if this category said animals, then 3 things you could write here would be dog, cat, bird. It would be 3 examples of this category. So chemical bonds is a category, and here they are. Okay, that's pretty much it. Now, depending on which force is holding the atoms together, the thing you get afterwards gets a different name. In other words, I'm going to try and stick to what I've been doing. In other words, let's just move this down a little bit. This atom on the left is attracted to this atom on the right. That's what all these arrows are for. Okay? However you want to think of these forces that are holding the atoms together, that's a different story. It depends on the type of bond. You need to go check out what a covalent bond is, or an ionic bond, or metallic bond. But whatever type of bond is holding them together, that will give you an idea of what to think about these arrows. Okay, so these arrows that I've drawn here, they don't represent anything in particular. I'm just showing you that this is some kind of force holding these two atoms together. And it does. I'm not saying there has to be 3 of them or 6 of them, or I'm not saying they have to come in pairs. I'm not trying to say anything about them at all. I'm just trying to say there must be some kind of force. Maybe if that's too confusing, I'll try this. Let's try and make it real simple. I'll do something like this. Okay, here's an arrow there, and then there's the other arrow on the other side. Okay, that top part's not the best. And now I want to do it all again. You have to forgive my artistic deficits. Okay, there you have it. They are being drawn towards one another, held together. The exact story of how they are held together depends on what type of bond you're talking about. But at the end of the day, we have now made another picture. We've made a new picture. It's more complicated, and this is how physics works. You keep on making more and more complicated pictures. So here is our new picture, and actually I want to use a color for that. Okay, we're gonna this green thing. So this green picture is our new picture. This black circle, by the way, let me remind you, we had a name for that picture. It was called the picture of an atom. This is the picture of a similar atom. This green thing also gets a name. This object, which is formed when atoms are held together by some force, gets a name. Just keep in mind, perhaps I will put in black here. I'll write etc. the same way I wrote etc. before. That etc. is there, ... because you are allowed to have more than 2 atoms. When you think about atoms being held together, you are only allowed to think about 2 atoms at a time. So each one of these bonds, covalent bond, ionic bond, metallic bond, can only be between 2 atoms at a time. If I want to chuck in a 3rd atom to be part of the story, I can, but then it has its own bond to either this atom or this atom, not both. So a bond that, like one of these 3 types that we see here, it only exists between pairs of atoms, never 3 or 4 or more. So if I wanted to throw in another atom here, I could, but then it would have a separate force of its own, like that. I hope that makes sense. That's a little attractive force that I've drawn there, and that will be a bond. It could be different. It doesn't have to be one of these types of bonds. That could be a metallic bond. But any bond you ever have will be between a pair of atoms, never 3. But you can have as many as you want. You can have 100 atoms in this green picture, as long as they are joined in pairs by one of these 3. As long as every pair in the green picture is joined by one of these 3, and they might be different. They don't all have to be the same. You could have 5 covalent bonds, 20 ionic bonds, and 30 metallic bonds, all in the same green picture. You can have a lot of atoms in that green picture. It's fine. Doesn't matter. You're allowed as many atoms in this green region, this green picture, as you want, as long as they are joined by one of these forces in pairs. Okay, let me take that away. Now, what we call this green thing, this black thing was called an atom. this picture. What do we call this green thing? It depends. It depends on which type of bond we have. Okay, if we have a covalent bond, then we call this green thing a molecule. If we have an ionic bond, then we call this green thing a formula unit. Okay, that's extremely confusing language. It doesn't need to be like that. This is basically the same thing as a molecule. It's almost like an ionic molecule. You can think of it as being essentially the same thing. They're so similar. It's not worth trying to remember the difference. It's a formula unit. I'll say IE, like a ionic molecule. It's sort of like an ionic molecule. And lastly, what do we call this green blob, this green picture? If it's a metallic bond, we call it a metal. That one's easy. So there you go. We've got a bigger picture. We started with a small picture and we are working our way up. Now if I ask you, I can ask you again. So let's grab these questions once more. Okay, I've kind of moved this thing that says another over here out the way, but I'm sure you can understand. Let's grab these questions again. I'm going to ask these questions again, except now I'm not going to use the word. This is another. I'm going to ask these questions again, except I'm not going to use the word atom this time. This time I'm going to use the word molecule. So instead of atom, I'm going to take that away. I don't want that, and I don't want that. I want the word molecule instead, so I'm just making space for my word molecule. Hopefully here it can go. There you go. I'm asking the exact same question. So here's question 1, here's question 2. I hope you see it's precisely the same set of questions as we were asking about atoms, except now we're asking them about molecules. Now you will see as you go up a level, by the way, this was like at the level of the atom. Now we're looking at the level of the molecule. You might notice that the answer to question 2 for atoms is the same as the answer to question 1 for molecules. They have the same answer. Let's say that in a different way. The force that keeps one atom close to another atom is the same force that keeps a molecule together. Why is that? Simple. Because a molecule is what you get when one atom is kept close to another atom. So if a molecule is what you get when one atom is kept close to another atom, then of course the force holding one atom close to another atom will be the same force that holds the molecule together. Because the molecule is only there because the atoms are being held together. So they're the same force. What force is that? It's one of these three. It's a chemical bond. So just to make that clear, what's the answer to question 2 up here? What keeps an atom close to another atom? A chemical bond does. What keeps a molecule from falling apart? What keeps a single molecule together? A chemical bond, the same thing. Answers are the same. That is why chemical bonds are also called, and I'll put AKA here, that is why chemical bonds are also called intramolecular forces. Because the word intra means inside. So these are the forces inside a molecule. And of course, the forces inside a molecule is the answer to question 1. It's what keeps a molecule from falling apart. The forces inside the molecule are what hold it together. And that is why the answer to question 1 here is what you would call an intramolecular force. It's holding the molecules together. Okay? And that's why it's also known as a chemical bond. And that is why if you refer to a chemical bond as an intermolecular force, or vice versa, you won't be wrong. That's perfectly okay. Now we have, hopefully you can see where this is going. We're almost at intermolecular forces now. Now we've got this green picture. In order to answer question 2, over here, this question 2, what keeps an atom? Oh, I have to actually change this into saying molecule as well. Let's do that, just because I don't want to make anyone confused. So let's change this quickly. What keeps a molecule close to another molecule? Okay, we're going to answer that question now. What keeps a molecule close to another molecule? I hope you can see, in order to answer that question, I need another picture of a molecule. I've only got one here. I need another one in order to check what keeps one molecule close to another. Okay, so let's just grab this quickly. I'm going to make a copy of it. Okay, I'm going to shrink this one down. So, actually, let me try to do a better job of that. Just want to avoid the red lines. Okay, I've got one. There it is. I'm going to shrink it down once more. There's our molecule. There's our wonderful molecule. Whoops. The green line has become a little bit hard to see. The green circle has become a little bit hard to see. So I'm going to draw it again. There you go. That green thing is a molecule. Simple. And we know a few facts about it. I want to answer question number 2, which means I need another molecule. Oopsie, that's not ideal. Let me make it a rectangular selection. Okay, there's my molecule. Here's another one. I've got 2 of them now. By the way, all of this stuff over here, all of the stuff you see, we can kind of do away with all of this stuff. All of this information that you see here pertains to an individual molecule, or what is going on inside an individual molecule. These are the intramolecular forces inside a molecule. We can kind of do away with them for now, but I don't really want to do that, so maybe let me just do something like this. I'm just going to cordon off that section, okay, because I don't want to have to think about it. Okay, so we kind of got a new section here. What's going on in our new section? Our new section, we're going to study what's happening with this story. Let me drag it down. There's our 2 things. Okay, so now we're talking about these 2 molecules. And finally, we have arrived at the interesting piece of information. It turns out that we can ask the same questions about this. We can ask what keeps a molecule close to another molecule, but we can grab these. Let me do it exactly the same to help show you the pattern. We can ask these questions again. Okay. Except over here, when we put 2 atoms together, we got a molecule, and that took us to the next stage of questions. Do you see? These 2 questions were about atoms. And when we put the atoms together, we got molecules, which gave us our next pair of questions. This one and this 2. What happens if you put 2 molecules together? Then you get the next set of questions. Okay, but the issue is, what happens when you put 2 molecules together? What do you get? Let me repeat this. This first set of questions is about atoms, and when you put atoms together, you get molecules. So that's what the next set of questions are about. And when you put molecules together, then that is what the next set of questions will be about. It will be about what happens when you put these things together. Molecules. By the way, we're not going to talk about formula units or metals, because that's not part of what this entire story is. Okay, the picture that you might need to have for a formula unit or metal is not as complicated or as interesting as the picture you need to have between 2 molecules. Okay, I will mention it, but it's not a big deal. Okay, what happens when you put molecules together, or formula units, or metals? This part doesn't actually matter which one of these three you're talking about. So when you've got two molecules, or two formula units, or two parts of a metal, whatever the case may be, what happens when you put them together? You get a substance. And that is what this is all about. Okay, that's what this entire story is about. This whole section is literally called it's called particles substances are made of, I think. Can't remember if it's particles. It's something that something are made of, that substances are made of. So this entire section is blah 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 that substances are made of. I think it's called particles that substances are made of. So we will finally need to talk about substances. Okay, so let's just do here. There you go. Now I've got substance. Now we can ask these questions once more. What keeps one substance together? What keeps a substance? Maybe I'll just need to move this over a bit. What keeps a substance close to another substance? There are two questions. Let me give them numbers. Number 1 and number 2. Okay, we're not going to answer question 2 because that's a different topic entirely. What keeps a substance close to another substance? That's probably a question for biology. You see, as we go up these steps in the ladder, we start with simple pictures of an atom, then we get a more complicated picture of a molecule or a formula unit or a metal. Then we get a more complicated picture of a substance. And as we step up from a substance, we get things like cells, living organisms, amalgamations, and those are things that are taught in other subjects, probably biology. When you put together a whole lot of cells, you can almost view the entire universe like this. When you put together a lot of cells, well, then you get an organ. That's still biology. When you put together a lot of cells and a lot of organs, you get a human. What's it called when you study humans? Maybe you still want to call it biology or life science. Okay, now you can put together a lot of humans. What is it called when you study a group of humans? What keeps humans together? What keeps one human from falling apart? That's maybe psychology. What keeps one human close to another human? That could be social studies. What if you have lots of humans? What keeps a group of humans together? That's politics. What keeps one group of humans close to another group of humans? Well, that's economics. Hopefully you can see as we go up this ladder of concepts, you study different subjects, all the way up till whatever the most complicated subject is, probably politics. But just so you see where we're going, we're not going to answer this question. Okay, the answer to this question leads you to biology, and we don't go there. However, let's answer this one, because this is the point of the video. What keeps a substance together? What keeps a substance together is whatever force we are talking about over here. In the same way that an atom was held together by a force between two things, in the same way that a molecule or a formula unit was held together by a force between two things. It turns out that a substance is held together by a force between two things as well, and those two things might be molecules. So to repeat one more time, atoms are held together by a force between two things. By the way, it's the electric force between protons and electrons. That's what atoms are held together by. Then we go to molecules. What holds molecules together? It's either a covalent bond or an ionic bond or a metallic bond, and you put it together, you get molecules. Okay, that's what holds a molecule together. Altogether, they're called chemical bonds. Then you could take a step up. What holds molecules together? Okay, I actually just answered that question. What holds molecules together? You take a step up to substances. What holds substances together? What holds substances together is these forces between molecules. And I hope you see how this fits into the picture that's getting bigger and bigger, a more and more complicated picture, which starts with atoms and how they are held together by the electric force, protons and electrons. Then we go to molecules and how those are held together by chemical bonds between atoms. Then we go to substances and how those are held together by the forces between molecules. And those are called intermolecular forces. That's what we are talking about. So when you are studying what holds substances together, it's this force that you see here between molecules, because molecules are usually what make up substances, along with formula units and metals. But as I said before, these are not that interesting. Those are like kind of exceptional cases to explain. It's easier to explain with just molecules. What's the special name for these things? They don't get a special name. It's a force between molecules, so we just call it what it is. We call it the intermolecular force. And that's very self-explanatory. Inter means between. So an intermolecular force is a force between molecules, and that's all we call it. Over here, the intramolecular forces get a special name. Chemical bonds. If we go inside and we look inside the atom, I could talk to you about the intra-atomic forces, the forces inside an atom. They have a special name. It's called the electric force. It's the electrostatic attraction between protons and electrons. Those are intra-atomic. These are the interatomic. What about intramolecular? Well, the intramolecular forces in red are the interatomic forces because they're between atoms. You can kind of see for every stage in the argument, the inter forces will be the intra forces for the next stage of the argument. Because what happens between things, what holds two of an object together, is precisely what holds together the bigger object that you get when you put the two smaller objects together. So just to say one last time, the interatomic forces are inside these atoms. Intra-atomic forces are inside the atoms. And that's the electrostatic force between protons and electrons. Then we go to the interatomic forces. Interatomic forces are these things. The interatomic forces are the intramolecular forces. They're the same thing, and they're normally called chemical bonds. Those are intramolecular. Now we go a step up, where the intramolecular forces turn into intermolecular forces. Do they get a special name? No. But this is what they are. They are the forces that hold molecules together, as opposed to the forces inside a molecule. They hold different molecules together. And what are they? They don't get a special name, but there are a lot of them. And I can't go through all of them now, but I will just remind you of what they look like. Let me move this completely out the way. They look something like this. There's a big list of them. And it goes something like this. Hydrogen bonding, that's the strongest intermolecular force. Then you get dipole-dipole. And then you get dipole-induced dipole. Right? My typing is gone. And you get blah, 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 to the weakest ones down here, which are called London dispersion forces. How do you decide which one of these you're dealing with? It's very simple. You look at the two molecules in your picture. Always remember that every stage of this entire argument has a picture that you should be thinking about. This is the picture you should be thinking about for intermolecular forces. You should be thinking about two molecules that are being drawn towards one another. How do you decide which of these things to choose from? You look at the two molecules. If they are both polar, well then it's dipole-dipole. If they are both non-polar, well then it's London dispersion forces. If one of them is a polar and the other one is not, then it's dipole-induced dipole. Okay, and there's a long list there. We don't have the time to go through it. But you read through it, Each force is associated with a certain type of molecule here and here. Hydrogen bonding is basically super strong dipole-dipole. It's what happens when your molecule is, first of all, polar, and second of all, has a hydrogen sticking out the edge connected to a nitrogen or an oxygen or a fluorine. You have to investigate hydrogen bonding on your own if you would like to find out more. But the point is, the way you decide from this huge list which one you want to talk about is that you think about this picture of two molecules with an intermolecular force between them. And you ask yourself, what type of molecule is this? Is it polar or is it non-polar? And then if you want to check for hydrogen bonding, you have to ask a few more questions about the molecule. But that's what an IMF is. It's part of this entire story where at each stage there's a picture. Okay, I hope that made sense. Just to give you the fastest summary in the world. This is the fastest summary you've ever seen. Here's an atom. What forces are inside? Intra-atomic. You get another atom. What forces between them? Interatomic, also known as intramolecular, also known as a chemical bond. Okay, great. Now we take that. It's probably going to be a molecule. This big blob might be a formula unit. It might be a metal. It's probably going to be a molecule. You need two of them. Those are two molecules. Guess what? There's a force holding them together as well. What is it called? It's called the intermolecular force. And now this is called the intramolecular force. Same as this one. So now these forces are going to be called intramolecular. Whereas before they were called interatomic. It's the same thing. You just use a different word if you want to talk about atoms or molecules. But now we're looking at this force. That's the intra-substance force, if you want to call it that. That is the force inside a substance. It's the intra-substance force, also known as intermolecular force. And that's where our story ends. So we begin with an atom. Two atoms are drawn together by an interatomic force, also known as an intramolecular force, also known as a chemical bond. When that happens, you get a molecule. Then two molecules can be drawn together by a thing called an intermolecular force. Not an intra. An intra is what we were speaking about previously, inside the molecule, between two atoms. Now you have an intermolecular force. When you draw together two molecules via an intermolecular force, you get a substance. The type of substance you get depends on the type of intermolecular force, and you need to look at that big list to decide which one it is. But that's it. It's a story of multiple levels. You start at the bottom level with atoms, you move your way up to when collections of atoms gives you molecules, and then up again to where collections of molecules give you substances. So it's a story with different layers, atoms to molecules to substances, and each layer has a picture that you should be thinking of when you think of that layer. And there are some words that go with each layer. For atoms it's interatomic, for molecules it's intermolecular. You see the point. For each layer there's a picture you should be thinking of, and there's a word you should have for the forces that are at play at that level. And by looking at the objects at that level, where there are atoms or molecules, you can decide what type of interatomic or intermolecular force you're dealing with. Okay, that's the end.